So welcome all of you for the 16th session. As I mentioned, we will have file handling first, and if you need a break we can have, otherwise we can continue with the exceptions. And instead of 7 to 8 having a break, I would like to complete the class by 8 p.m. so that you will have a continuous 2 hours of break in between. I'm sure you are all looking for some free time to study. So let us make use of this opportunity. What I plan to do in this week is, as I mentioned, these two such topics will be covered. Then I want to cover GUI using Tincter tomorrow. And if possible, instead of Wednesday class, we can move that into Tuesday. And I want to do two things. Socket programming is supposed to be socket. And then just a SQL, how to access an SQL database, a small example. And then some GUI features, how to write or draw pictures, we will have it. So these are the three things I would like to cover in this week. So let us see how we can do, whether all three of them on the same day tomorrow. There's not going to be a lab this week. Only these topics we will be covering. Okay. So let me. Okay. So let us start with file handling. I'll call them as 16 only, section 16, both topics, even though we have a break in between or into the next class. So before I go into this, let us just understand in general how files are being handled by the system. Though it's a repetition from the OS course, I thought I will give you something, some introduction to recap. We have a hard disk. It's no more hard disk. We have now SD card, and then SD memories or flash memories. Both SD card and flash memory are the same. The technology, or even the USB pen drive, what you have, all of them use the same technology, which is a flash memory. Now, what is the difference between a flash memory and a hard disk? In the hard disk we have platters which are rotating at a very high RPM, thousands of RPM. And then we have sectors, and each of these platters have both sides of magnetic material, and then we have blocks of memory where the files are stored. Now, the hard disk works this way, that we have a reader which can be positioned anywhere, and it picks up due to magnetic disturbance that happens due to this, which is very close to this disk, and it picks up those energy and then it sends it to the controller, hard disk controller, which is actually a dedicated ARM based processor. Okay, mostly because when I was in LSI, we have supplied SoCs which go into the hard disk of Seagate or Western Digital. They use a full-fledged processor with both ARM-based core as well as some FPGAs, and it also has some memory. Now, this hard disk controller is the interface which is controlling the read drive. Okay, and then they move this at, you can imagine the speed with which these disks rotate, thousands of RPM, and the accuracy of reading these bits are very, very important. And because of this kind of a small gap here, we will have lots of noise also. So there is a lot of noise cancellation or error correction algorithms being done here, so that what is stored and what is being read, they are verified with those ECC or error correcting codes. So that kind of a bigger processing is done by the hard disk controller to read those bits coming from this disk at a very high rate. Now, when you are reading the files, that whatever we read is um, understood by the OS. Of course, OS is providing the interface to the hard disk. Hard disk does the translation of where exactly the blocks of memory files are stored here. Now, OS also need to have some knowledge. That's why you have some inode in Linux, whereas Windows is operating on different technologies, but Linux uses the inode, which you may be aware that it has 10 direct modes, direct blocks. It accesses the direct blocks of the hard disk, the 10 interfaces inode has. So if your file is of maybe 40 kilobyte and your block size in the hard disk is 4 kilobyte, then the first 10 blocks in the memory are stored in those hard disk in some places anywhere. It could be distributed all over. Mostly the disk controller will try to keep them in the same sector so that it can be picked up continuously by reading these sectors. But if the files are being stored and deleted, there are some holes there, and it cannot find a contiguous space in the disk, so it stores somewhere. So this inode structure, which is in the Linux, keeps track of the blocks where this a particular file, first 4 kilobyte is stored, and next 4 kilobytes, where is it stored in the hard disk. That information is captured here, which is given to the hard disk controller, and hard disk controller job is to only control the read drive and position it and read it and make sure that what it reads is error free, and it will buffer them and DMA through a DMA, direct memory access, I will tell you about that, and moves it to the memory. Then it is given to the OS, and OS gives it to the application. So when we do all this, the file itself is handled by the OS, and it decides that structure of the way it is laid out in the hard disk. And we have a boot area, and then this is a file handlers in inode I am telling in Linux, and then we have the data blocks, which is where actual data is stored. So maybe let me leave the discussion only to the Linux, wherein the file blocks, the data blocks are only having the data of the file. Okay, if suppose you are storing maybe hello world in the file, the hello world content is stored in this data block. So the inode actually refers to this block, and OS knows where this file structure is and which inode is used, and then it gets the content of the file which is stored in the memory or in the hard disk. Sorry. Now the hard disk can be formatted. When you do format, we are actually deciding how much is the size of those blocks. In fact, these are all frozen because the hard disk controller decides what kind of block sizes we need to keep it in the hard disk. We don't have that freedom, but we can actually, like formatting, when we format it to D drive or C drive, or maybe different file systems in Linux, wherein we capture it as a root directory and then rest of it is the subdirectories. That way we laid out the different blocks in the hard disk, and then we give the hardware controller or disk controller to control it. Now when you store a hello world, what happens in the 4 kilobyte block is the only hello world will be stored, the rest of the block is wasted. Okay, this is what is called internal fragmentation, where you may read it in main memory, but even in the in the hard disk, internal fragmentation happens where you have a huge data blocks and the files contents are all small. Then you have more of internal fragmentation. And then, as I mentioned, when the hard disk is, a lot of files are stored and then they are deleted, you will have gaps in the sector, which is called external fragmentation, wherein you are not able to keep the files in the contiguous spaces, so you have to distribute it all around the place. So this internal fragmentation and external fragmentation comes not only in terms of hard disk, but actually mainly it is in the main memory, where you are not able to keep the contents in the sequence. But it is also very obvious and very popularly discussed about in the OS paradigm, where these blocks of memories are distributed all over the hard disk, and you may do a refragmentation or a segmentation fragmentation you may do to make it compact. So that is why it takes a lot of time, because it has to copy the content from one sector to other sector in the hard disk. Now these are all about hard disk. Now let's just give me let me give a brief overview of flash memory. The flash memory is also, that it is a non-volatile. That means you need to keep the power for the SD card or a USB pen drive that you have to hold the value. Now, how does the flash memory differ from hard disk? Because there is no rotating business here. There is nothing rotating here, or there is no magnetic features in the flash memory. Flash memory has a floating gate. Okay, if you are from electronics background, you may understand this picture what I am drawing. Source, drain, and then gate. So this is a gate, normally FET gate or field effect transistor. Floating gate is one method of storing one bit, okay, in a small semiconductor gate. Okay, it's like a small transistor where the charges are stored inside the gate. So yeah, one bit is stored as a floating gate here. Because it is called a floating gate, literally it is the charges are trapped in a place where the either negative or positive, that is stored in the floating gate. Now, how does it store information? Even if you withdraw the power on the flash, it is because this floating gate, whatever it traps the charges, it retains it. Even if there is no power, there is no way of this charges getting leaked to the ground or getting discharged. So it holds the information that 1 is stored or 0 is stored. Okay. Now, the flash memory is has a time limit. Okay, if you maybe 20 years or something, if you keep your pen drive for long, this flash memory slowly deteriorate, and then they lose the charges, and you may not be able to retrieve the content if you have stored it in the flash memory, and if you keep it for a long. But if you are accessing it, maybe reading, writing, it will again recharge this content, and it retains the information. Now, another thing you need to remember about flash memory is that you cannot erase a single bit or the DRAM or something. You can SRAM. You can specifically go to a particular bit and then make it 0 or 1. Whereas in a flash memory, you need to do it in a block, like what you do in hard disk. You cannot store only single file. You take the whole block in the hard disk and replace it. Okay, if you are reading even a byte from the file, you need to read the whole block from the hard disk. Similarly, if you are reading a single byte from the flash memory, it doesn't give you only 1 byte, but it gives you a block of maybe 128 kilobyte, or not 128, I think maybe 256 or bytes or something. Okay, it depends on different flash memory, but more condensed flash memory will have a higher block rate. You need to read it in blocks and then write it into a flash memory also in blocks. So that way you are retaining or refreshing the content of the flash memory. So this is just an overview of how flash memory and hard disk work. And flash memory doesn't have any rotating things, and it is reliable, and you don't need to worry about accessing it while you are in transit. That's why our mobiles are safe. Whereas when you are accessing the laptop or with the hard disk, which is rotating at thousands of RPM, it is preferable not to run the thing or access the hard disk when if it is vibrating a lot, movement is more, maybe it may get damaged. Okay, hard disk may be damaged. That's why when you are taking the laptop, better to shut down if the hard disk is there. But if your laptop has a SD card memory, most of the recent Dell laptops come with that, or any other laptops also, where most of the file, whatever you are now, suppose if you are making it laptop to sleep, the content of the RAM, the memory, main memory content is stored in the SD card or SD memory, not in the hard disk. So even if you make the laptop sleep, the main memory contents are moved to this and which will be safer. Okay, even if power is there, if it is powered on. Okay, fine. Now let me talk about the hard disk and file handling. So OS does the interface between the hard disk controller and then which is accessing the hard disk. Let us assume that hard disk is only the file handling. Now whatever files being accessed is block is brought to the hard disk controller, and it verifies the content and then transfer it to the memory. So this transfer of the content from the SOC of hard disk controller to the main memory happens mostly by the DMA, which is the direct memory access, where the OS is not involved. The OS only gives a pointer in the main memory. It blocks one particular page in the main memory and then gives to the controller that whatever file you read, the block of memory or a block of file content, you copy to this particular area. So this is be blocked. It is locked in the sense this will not be swapped out to the hard disk just because there is no space in the main memory. So because if it is swapped out, then the hard disk cannot, controller cannot write into this area. So whenever you are saying that I want to read a file, a block of content is read and OS reserves a space in the memory, main memory, a particular page, and then it gives a control to the controller and then forgets it. And then OS will be notified when the controller really copies it from the hard disk and puts it into the main memory and informs the OS. Now, once OS gets a control information that the hardware controller has copied it, the file content is here, and then it returns to the user application, whether it is a C program or a Python program, doesn't matter. It gives you the pointer where exactly this particular file content is stored. Now you know that this is in the physical memory, and what pointer you get is a logical memory. Okay, or it is actually in terms of file. So it is different from the code and data area that you normally see. So file handler or file descriptor, FD or file descriptor, has the information about this translation, okay, where exactly in the main memory the content is, and then you will be able to access it. So this whole lot of story happens before the file access happens. Now let us look at how Python helps us in handling the files. Now, even though various file formats are supported by various OSs, okay, the built-in methods in Python can handle only two major type of files. Okay, Python has only two different types of files. One is a text file, other one is a binary file. Now, mostly you know the difference between the text file and the binary file. Text file is the contents of each byte is encoded, okay, normally ASCII, but may not be always ASCII encoding. It could be UTF-8 or whatever the file format is, but it depends on the way the text file itself is stored. But normally we can assume it to be an ASCII encoding, but because of different languages coming, ASCII was not sufficient, and then there were, as I mentioned earlier, UTF-16 or 8 encodings, or all different encodings were done for handling the different languages. So that is how they are all stored. Now, binary file is treating the byte content as a binary information, and it gets stored in the hard disk finally. So effectively what is being stored in a hard disk or in a flash memory is just a array of bytes, So it doesn't have any other information, whether it is a PDF file or PDF or a Word document or a executable or a library. Everything is a binary bytes of content, but the executable and Word and PDF files are all treated like a binary file because they are not falling under the text file configuration. So it will be understood only by the respective tools. Maybe Word document can read the Word file, or PowerPoint can understand the PPT format, but they are finally binary content inside the hard disk. So the file processing in Python is done by two different types of approaches. Now, how do we process it? One is processing the content in the file. Now, what we need is we want to go through the content of the file, or we want to go through the directory. Okay, so in Unix or Linux, even the directory entry is a file. The directory entry is also a file. So maybe it's a file name and then the INODE number, file name and inode number, or the sequence of a series of dictionary kind of a thing is retained in the content of a directory. So directory is nothing but a list of files which are nothing but referring to a particular inode entry, which is giving you the actual file content, okay, data blocks. So there are two processing. One is processing the file content, another one is processing the directory content. So if you are running through a directory in a file system, you need to understand the way the directory is configured or is stored in the hard disk. So that's why different file systems have different formats, like Mac and Linux or ext2. Different file systems are there, FAT32 or NTFS. A lot of file systems are there. So they all have different way of storing the files in the directory, and all these device drivers of the OS, they take care of the file system. So OS and file systems are related, and they take care of how to interpret your commands. So any file related activities that you give it to the Python is blindly taken and given to the OS, and OS handles the rest of it. And then whatever OS returns it is what is returned by the Python program for us. So the first one can be done in built-in functions. So whatever file handling that you want to do, actual content, if you are interested in going through, when I say actual file content means you want to read 10 bytes or 20 bytes, or maybe you want to skip something and then read something else. So those content, if you want to skip through or read through them, built-in functions are there to handle it. And then the second one, which is directory structure, is handled by the OS module. So why am I saying, do not think that this is completely handled by the built-in. Remember, once the contents are given, the file contents are given, then the Python built-in program can take it. They can process it. But getting the content from the hard disk or from the flash memory is still with the OS. So do not read that completely Python takes care of everything, because the file content has to come, as I mentioned, into the main memory only with the help of OS, because that only understands the file system. And once it is here, the file content is handled by the Python in built-in function, because it is a byte, which is array of bytes given to the Python program. I hope there are no questions here, but just I'm going very fast. But you can stop me in between now, or maybe when I tell you when we are breaking from one topic to the other. Now, there are different access modes supported by Python built-in functions, which are read and write, append, and all this, which you might have already aware of. So let me just show you this. Read is opening a file for read purpose. So if you write into the file, if you have opened it for read only, then it will not allow you to write into the file. Now, how does the control happens? Because OS takes care of making sure that you don't by mistake write into the area, because that block of memory which is in the main memory, the file content, is only made as a read only. So memory protection is taken care of by the OS, and you will not be able to write into it. Not only you, even the other processors cannot do that. And write means without reading you cannot write into a file. So write means that you are reading the file and then writing into it. But the way Python handles is, if you are creating a new file, if it doesn't exist, it doesn't give you an error, and it opens it silently for you and gives you that, or truncates the file if it exists. So it will just make it 0 and then gives you without giving any warning, or sometimes it may give warning. But if suppose there is a file with a name f.text, and then you are opening it for writing purpose, even if you have a content, it will be made as a 0, and then it is giving you to write it. So you have to open it for a append mode. In that case, then the previous content will be retained and you will be allowed to write from the end of it. But you can also seek or do some in between also. You can write it, overwrite it, but normally append means it is at the end of the file which you will be able to append it. So it will not destroy the previous content. And the exclusive access is for, if the file already exists, the operation fails. Okay, it is for exclusive creation of a file. That means the Python program is creating it for the first time, and it doesn't expect that file to be already there in the directory. But I am not going to show you an example of it, but you are free to try it out yourself. and then T is a text mode if you want to open a file in the text mode or a binary mode. Then plus is always to say that you are doing a reading and a writing, both R plus or write plus. Is more or less they have followed the conventions of Linux in this case. Okay, now actually I have already explained this in the when I told you that whatever the contents are, they are buffered. Now maybe I did not tell you exactly buffering. What happens is when you are accessing the file, the fact that it has to go to the hard disk and then access it, and the controller is coming into play, hard disk controller. So there is a lot of delay, and then not only this, even seeking the disk, accessing it, the read port, and then getting it from there is lots of milliseconds of time is lost. Okay, 200 millisecond or 100 millisecond or something like that. So what happens in the OS does it does a buffering of the content prior to what you want it. So suppose if you are reading a file, a bigger file of size maybe 10K, it reads the 4K content in the block and moves it to the main memory, and then it reads ahead other content, other series of sequence of that file. First 4K is read here. The next 4K of file is read somewhere else. It need not be in the contiguous space. It can be somewhere in the main memory. So it keeps it ready for you when you are going away from this and then trying to access the next pointer in the file. Then you are having already in the main memory. So you don't need to wait for that to be available from the hard disk. So that is what is called the buffering in file operation, which is automatically done by Linux also, and Windows also does it. So buffering is the process of storing a chunk of a file in a temporary memory. When I say memory here, it is a main memory. Okay, the DRAM, whatever we have in main memory, it is stored. So and memory until the file loads completely. Sometimes buffering is actually this point refers to the hard disk controller memory, but normally buffering is done by Linux or Windows also on the main memory itself. Okay, it is brought into the main memory. There is a separate memory is reserved for that, so that the file accesses are faster. So in Python, there are different values can be given. Okay, you can actually say whether you want the buffering to be enabled or not. If it is set to 0, then the buffering is off. The buffering will be set to 1 when we need to buffer the file. Okay, that will be much faster when you are accessing a bigger data files. Enable the buffering so that OS actually don't think that if you enable buffering, it is going to slow down your access, but actually it is going to enhance your performance of the Python program, because OS will do it in the background. It is not going to slow it down your program. And as I mentioned, the direct memory access, wherein the processor will not be involved, the DMA controller takes care of moving the content from hard disk controller to the main memory buffering. Okay, the buffering happens, so you don't need to worry about slowing down. Actually, it enhances the performance of the program because it is done in the background and not even CPU is involved in doing that. So giving a 1 here, it really helps you to get some benefit, especially when you are having a large machine learning models, or you are taking a huge data or images for training image files or whatever. So enabling this will really help you, or a voice data or video data, especially video streams. If you are accessing it from the hard disk files, bigger video files, MOE files or something, enabling buffering will be a better option. So enabling buffering means the Python program is not directly interfacing with the OS representation of a file. It's file system API for every file access. So when you do this, it's actually the notification to the OS that I want the buffering to be done. Okay, so it improves the performance from the programmer perspective, application perspective. Now, instead, a chunk of data is read from the raw OSV file stream into a buffer until it is consumed by the program, at which point more data is fetched into the buffer. So what I mean to say is, if suppose the file stream is what is coming from the file, let us assume that hard disk is there, and it's a large video file. This is called a file stream. Now you are reading this block by block, as I mentioned, and it is available in the main memory. As you consume this, by the Python program is consuming it, and then going the file pointer to the next one, you are already having this data. So when you ask for this block of data from the OS, it already has it in the main memory and returns it back to you immediately. So otherwise your Python program will be blocked for a while and then only woken up when the data is ready. So that way you can actually enhance the performance if you do buffering. Enabling buffering option improves performance, especially when the file size is larger than the default buffer size, 8 kilobyte in size. Okay. Normally, this buffer size is 8 kilobytes. Okay. Now, there are multiple things when this buffer size is the Python's decision. Okay. Python says that my buffer size is 8 kilobyte. Now, Python wants some 8 kilobyte of memory. Okay. Data memory. This is the main memory reserved for the file content to be put here. Now this itself may be a multiple pages. Okay, page size could be 4 kilobyte. Okay, normally we see that 4 kilobyte is the page size because if you increase the page size more than 4 kilobyte, what happens is, even for storing, as I mentioned, even for bringing one small file, 1 byte of data, 4 kilobyte of main memory is taken. So page size, if it is larger, internal fragmentation will be more. So it is not an optimal utilization of the main memory available to you. And then even copying and restoring it back from the hard disk is also a pain, because if this hard disk also 8 kilobyte, then it brings the 8 kilobyte of data, and then you may use only 1 byte of data, and then rest of it is not even consumed. So this size, page size cannot be arbitrarily larger. So normally it's 4 kilobyte is what is being used. Some maybe high-end high performance computing or the high-end servers may have a larger page sizes. So when the Python says 8 kilobyte, it is internally handled by the OS for giving this 8 kilobyte of data into maybe 2 chunks of 4 kilobyte pages. Okay, it may be contiguous or it can be in different places, but the file management or MMU will handle the translation. So it doesn't matter whether the 4 kilobyte is stored contiguously or it can be in anywhere in the main memory. Still, MMU gives you contiguous space from the virtual memory address perspective. So when you do a 8 kilobyte buffer size, what happens is, if you are training data or the data whatever you are accessing it of a huge size, then you are actually bringing 8 kilobyte at a time, or informing the OS that I am looking for 8 kilobyte of data. So OS will bring it in 2 stages, maybe 4 kilobyte at a time, but still make sure that 8 kilobyte of data is brought in, and then Python is informed. Python process is informed, or your application is informed, and you can consume 8 kilobyte of data. Okay, so this is a default buffer size, but you are free to change it to any other size if you want. And this all about the file handling. Okay, I think I might have given you more information than what is required. I don't know, but let me know whether you have any questions here on what I told you so far.
Yes, sir.
Yeah.
Sir, in case we have like 1 GB main memory, and we have getting the data or 2 GB from the secondary memory. So how to read it? Like the main memory size small, and we are trying to getting.
Okay, 1 second. Let me understand your program. Main memory is 1 GB or 4 GB. Okay, normally we have. Okay.
And the data size is 8 GB. You can think so.
Okay. Yeah. Your data file, right?
Yes, data file is more than the main memory.
Yeah. I will tell you. See, always the main thing is locality of reference. Okay, this is the beauty of locality of reference. You should always remember, anything in everything that works in computing is because of this beautiful concept called locality of reference. So what is locality of reference? Nowhere in your program, okay, I can assure you, nowhere in your program, not a program, I am writing a program, nowhere in your program or a code you need all the 8 GB of your data. Okay, it's not always it's true with respect to the code which is running. Even your code size, suppose your program size, which is nothing but a code size, okay, is also could be huge. It could be maybe 8 kilobyte of size, or your executable size may be even bigger than that, maybe 10 kilobytes, suppose your executable. And even executable is of content, code and data sizes could be huge. Even if code is huge, even if data is huge in terms of tens of hundreds of kilobyte, nowhere in your program or a execution you need all the data to be available in your main memory, or all the code to be available in your main memory, or even all the file to be available in your main memory. Okay, it's the that is the beauty of locality of reference. So what happens is the whole concept of MMU coming into play, memory management unit, helps you in abstracting out this information. And OS also, MMU is a hardware, OS is software. They work in tandem and they work with each other. They understand it. OS only configures the MMU to give you a feeling that whatever you need from the program perspective is available to you. It's only a imagination, or in fact it's not even possible at all humanly that whatever a program needs is available before it starts executing. So let me explain. When you are writing if I say that your program itself is of very high size and your page size is only 4 kilobyte, imagine your program code itself takes 10 kilobyte. Okay, now you cannot keep it all 10 kilobyte in one page. Okay, let me assume that when the code is brought into the main memory, okay, of your code, you may come where somewhere you will say main program is here. So your part of the code, main program is here, maybe library program is here, and some other functions what you have written is somewhere here. So what you start executing is the main program. So what is brought into the main memory is only the what is currently needed. It's like when you start off your semester, you are not going to read the whole semester syllabus in a day, first day. When you start reading for every week, when you are studying only what is being covered in that week, or maybe some people do it in advance. I don't think so. Looking at all our student life, I know if you are following what is being handled, itself is a great thing, right? So even the CPU, your computer or OS doesn't bother about what you may need it in the long future. Okay, maybe near future it worries, that's why buffering is happening, but it is not going to bother about what is going to happen after some when the program is running for some 10 seconds or maybe 1 hour or 2 hours. So to answer your question, 8 GB of data, even if you have, what is brought into the main memory is not even 4 GB. Please don't think that all 4 GB is to you. You are not even having, if you are running Windows, I'm sorry, if you are running Windows, okay, I hope you are not related to Satya Nadella. Windows occupies almost like 1 GB of space. I understand earlier my reading. In the main memory or even Linux, okay, what happens, the operating system needs to occupy the main memory first before anything else starts. And remember, nothing can be executed by the CPU unless that code or data or whatever information is brought into the main memory. It cannot be executed anywhere else, from anywhere else. You cannot execute a program from hard disk. You cannot execute a program from the flash drive. So it needs to be in the main memory, and OS code also has to be in the main memory. So that is always residing most of the time. Okay, maybe some special libraries of OS may be brought into the hard disk at a different point in time, but the dynamic library, link library, those things are brought based on the need, but OS resides in the main memory. So what you have may not be even 4 GB. You may have some 3 GB of space. So your 8 GB cannot be accommodated here. So what happens is only the portion of data which is being accessed by your code is brought into the main memory. And when you move to some other location in your file, your program is stopped and the OS is asked to bring it to the main memory, and then the control is given to you. So you don't even know that you were stopped and then resumed later on. So that is happening in the background. Do not think that only your program is running in the CPU, because you know very well that even if you have a 4 core, all your code is not running always. There are other applications competing for the CPU. So you come into CPU once in a while. When I say your program comes into the CPU once in a while and goes out more often, and still you feel the continuity because it is transparent to you the way OS makes sure that it is hidden. So all that boils down to locality of reference, because even your code or data or a file is only a part of it is being used at a time. So only when you need it, it's brought into the main memory, and only when it is needed by the CPU, okay, when it is needed into the CPU, it is brought into the cache, L1 cache or L2 cache or even L3 cache. They're all brought in from the main memory. They are brought into this and then given to the CPU. This is a sequence of things. So whatever is needed from here comes here, a bigger chunk comes here, part of it comes here, and the small portion comes here, and maybe one data comes to the CPU. So that's how the whole data movement happens, and this is how the locality of reference helps us in terms of running our code. Did I answer your code? Question.
Yes. Yes, sir.
Okay. Any questions from anyone? Okay, now let us look at the code now. Okay, I think I have whatever I wanted to explain in the theory is done. So let me take only this much. Actually, so far I did not talk about something. Okay, this window, whatever the console window, what I am talking about, is actually like a terminal in your command window. So suppose if I write a command window, it has the directory where it opens up, and then I can see the I can see the files here, right? So this is a process, command prompt process is running in this particular directory. So even the Python exe, okay, the Python pvm is running from a particular directory. This is the directory where I am running this particular console from. Why am I bringing it here? Because when I am trying to open a file, it is going to refer to the directory where the Python console. I'm not saying Python console, okay, please don't read it, because it is shown here as a console, is a Python executable. Suppose if you are running it off as a process, if suppose as I told you, multiprocessing, where we create a new process, then the new process has to run in response to a, or not in response, with reference to a particular directory. Okay, any process running in a OS has to have a directory from where it is running. Why is it so? As long as you don't do any file handling, then no problem. Okay, if you are not doing any file handling, it doesn't matter whether the process is running from with reference to any directory or not, doesn't matter. But suppose if you are trying to access a file, then the process need to have a directory where it is running from. Suppose if I say that it is running from a directory C:/ maybe Mauly, and then / maybe temp. Now if I say I want to open a file, I want to say just say open a file a.text. Now this is the not absolute path. When I say a.text, it is not an absolute path. Now when I try to open a file like this, it should know from which directory. You cannot always assume that it is going to be a root directory. In Windows, what happens? Root directory or multiple root directories are there: C:, D:, E:. At least Linux doesn't have that problem, because root directory is only one directory, and then the rest of the file systems are mounted onto some other subdirectory. Whereas we have a different file system on the Windows, where every partition is a root directory. So if I say a.text, Python does not even know which one are you referring to. Is it C:/ a.text you want me to open, or D: you want to open, or E: you want to open? It doesn't know. And because of this, what is done is it should have some reference, right? So when the process is created, or when this program is running, or when a Python exe is executed, it opens in a particular directory. It is assumed to be opening in a particular directory. So in this case, this is opening in this place. I have given double slash here. It is showing because it is unique, between Unix and Linux. We have a backslash and forward slash. So it is showing it this way. Okay, whenever you are trying to access a directory, you are to give this, but it internally converts it because it knows that it is running on Python Windows platform. But when it is shown like this. So why am I saying all this? When I say, if I say a.text I want to open, the Python, what does it do? It looks for that particular file in this particular directory where this exe is running, the whole PVM is running. Now what if it doesn't find it? So there is a method, I have to go into the path variable, okay, path variable, where environment variable is also passed to this. Okay, remember, okay, just a digression. If you know that in C program also you have args, argv, okay, and then envp, I think pnv or envv, okay, envp, okay. So the main program is getting all these things into the program application. Okay, so it is also getting the environment variables passed to this main program. So when if you are creating a C program executable, even a simple hello world knows where exactly this hello world executable is invoked from, because envp, which is a hidden parameter passed to the main program, which is having the content of all the environment variables. So OS maintains the environment variables like path, which you might have heard about it, and then there are many environment variables are there in the system. So it is initialized with series of some file system, okay, semicolon or colon, based on the Linux or Windows, a different path is given. So what does the Python do? It will check whether the file that you are opening, which is an absolute, you are not given a relative path, only you are given absolute path, you are not given. So it will just a.text you are given. So it will look for a current directory. If it doesn't find it, it may look for the path variable, and then it also has a special path variable which I have not mentioned earlier. It's a Python path. Okay, this Python path, I hope it opens. We can add it. I have not added it. So you can add a path to this, okay, Python path. Now, this is the environment variable which is not initialized, okay, and the IDE gives you the flexibility to initialize it. So you can add more number of path in the directory structure, okay. So Python path, you can initialize it. Now, randomly I chose something which happens to be the same file directory. So I'm not going to enable it. But if I add this path, what happens is, if the file is not found in the directory, suppose if I am not opening this in this CLS try, somewhere else I opened, that is the current directory of the console. If it is not found there, it will come to the Python path and searches in this path. It will look for every directory path one by one in the order in which you are given and looks for that file. If it is not found anywhere, then it doesn't know where to look for your file and then gives you an error. So now don't think that Python is doing, it's actually OS is doing. Please remember, Python doesn't even understand the directory structure underneath, because Python is agnostic to the OS. It doesn't even know on which OS it is running. When you are running the Python program, it is inside the PVM, well protected. It doesn't even know what is the OS underneath. It could be Windows or Linux or Unix or Solaris or whatever. So it is the job of the OS library to take care of these nitty-gritties, but Python variable is specific to the Python PVM, okay, the Python path. So it is, if it is initialized, then it will look, the OS will take care that because OS knows that it is the request is from the PVM. So that much knowledge OS has, okay, who is calling it. So it will look for this in the path, and then it will look into the path variable based on the OS, and then it will look into each of the directories and look for that particular a.text what you are trying to open. Now, what if you don't give a specific file name? You give an absolute path. Suppose you say, C:/Mauli and then /something/ and then a.text. then you are specifically telling that I want you to search for this particular file in this place, look for it. So only absolute path if you are given, then it doesn't have to look into this all these various Python path and variable Python path or a current directory. It will not look into the even current directory, because you are specifically telling I want you to open a file which is in this directory path. So it goes one by one. Please remember, it will not go directly here. It cannot go, because OS has to help first C colon. It has to find out, maybe if you are given D colon and D colon is not there in the file directory file system, then it cannot even find out. So it has to go to every thing entry. It has to look for. Mauli may be there, but this directory may not be there, or this may be there, next may not be. So it will be traversing through this. So the OS takes care of doing it for you. If it encounters any problem anywhere on the path, or even the final path is not there, then the standard error is given, file not found error. So that is coming directly from the OS, and OS is giving it from the direct file system, and then Python is just displaying it for you, but it doesn't even know what is underneath. So that is how file system is accessed. So to come back to this, you need to know where exactly this particular thing is running if you are trying to use or trying to access some file which is there. Okay, now I am trying to okay, I'll stop for a while. I'll finish the file system and then we'll have a break. Any questions from anyone? Maybe whatever I explained. Okay, now let us see. I'll run this. I'm sorry. So what happens? It is give you the same directory, because this is current working directory. Here this is present working directory, pwd. Okay, it's similar to Unix commands. So you can even see directories, ls ls command. You can look at the content of the file. Okay, some commands you can run it here. Okay, now let me go to the next one. Okay, I want to open a file. Now what do I want? I want a text1.txt. So the console is here, and current working directory also say that pws this printout came. Okay, when is it? When I run the program, it says that current working directory is here, cls try. So let us look at the directory content. Text1.txt is there. Okay, in the current directory. So what I should do? I don't want to actually run it from here. I want to actually run it from the class, because I am the class file, not a try directory. So let me do one thing. Let me change the preference now. Okay, preference, current working directory. What you do, you can traverse through the file structure. I want to keep it in the class because I am running it in the class directory. Okay, I am selecting this folder forcibly. Okay, fine, I did that. Now let me check whether this guy has taken the command or not. Okay, it doesn't. Okay, it is still in the try directory. Okay, do not assume if you have changed this here, that means that it has gone really there. Okay, let me tell you, even though following directory is the current directory, I did not say class/try, I said class only, but it has not gone there. The thing is, this console was opened before this change was done. So this process is already running. Now this SD IDE doesn't on the fly doesn't take care of your changes there and then moves this process to the another directory. It can be done. I'm not saying that it's not possible to be done, but this IDE does not do. So what do? I need to open a new console. So let me open a new console. Now let the old console be there. Okay, this old console still continues to be in the try directory. Now it doesn't matter. Let us look at this new directory, whether it has come to the new one. This is just taken the command that I have given. Okay, so what happens whenever you open a console, it is reading this whatever is the configuration you have given, and it is opening the console, the Python exe in this directory. Okay, now in the CLS directory, let us see whether we have a file called text. Okay, sorry, ls. I don't have a file called text1. Okay, test is there, database file, db file, but I don't have a text.1. Now what did I say? Read file means read file said that opens a file for reading by default, so it should be existing, the file should be there in the directory. Now as I mentioned, I have given a absolute yeah, I have not given a relative path. Sorry, actually I have given a relative path. Please, even though I have not given any path at all, it's a relative path. A relative in the sense relative to the current directory. Okay, so it is relative to the current directory. It's not absolute path. Absolute path means it should start with a slash. Okay, C colon something. Now slash something. Now it's not from the directory starting from the root directory. So it's a relative path. Relative path means it's a current directory where this Python exe is running from. Because you know that when I run this program, it is going to run in this instance only, because you have already checked it, OS, PPD, PID, PPID, all that we have checked, because this code runs in this same Python exe what you have. Now, if I run it from when I have these consoles, when whatever is the active console, it is going to run that code. So let us run it from this console, which is a try directory where text1 file is there. So if I do it, it works properly because try directory has the file which I told you, it has got this file. Whereas if I run it from this console, which doesn't have the text.1, the same program, when I run it from this console, I am not able to run it. Remember, what you run here runs on the console which is active here. Okay, so it doesn't not only means active, also where exactly this active window is running, this Python exe is running from. Because in the meantime, I changed the current directory there. This guy is running from a different directory than the other one. So this doesn't have the file, then I have a problem. Now what do? Let me bring it from that place. So what I do, I intentionally try to do this so that you understand this difference. And now I want to actually do, I am very lazy, I want to use this file, okay, which I have already written, bring here. Okay, now text1 is there. Okay, now OS is very context sensitive, so let us now look at this. You have this. Now this file has, what happens when you give a ls command, it is asking the OS to execute the ls command and give you the list of direct files which are there in the directory. So since OS has taken care of bringing the file here, you are getting it here. Now since you have it here, if I run it from on this console, this works fine. Okay, now file opens without any problem. Now I am just printing the object. What is the type of the file? It's a IO wrapper, which is a text file. Okay, so as I told you, binary file and text file are the only two contents that Python recognize it. So IO text is here. Okay, so it's a text file. It does recognize that it is a text file, and you opened it here. Now let us try to take some more read line. Okay, let me complete it before we break. Okay, I think we need a break maybe. Let me complete it. Hopefully this will go very fast. Okay, now I am reading a line. Okay, that's very straightforward, I don't need to explain this. So read a line. Now how does it know? Maybe a small thing I will tell you what is reading a line. Little bit of I don't like to read. Okay, this is also fine. Now you see this file is not having any carriage return at the end. They have this. Now I hope you guys know the difference between the files, how text files are stored in the ways. Windows and Windows, Linux called or Unix, and Mac, especially text file. Okay, there are two values: carriage return and line feed. Carriage return value is 0x. Okay, it doesn't matter 0x or something. Not 0x. Okay, carriage return is 13. LF is 10. Okay, it's not OX. It's just a 13 decimal number. This is ASCII value of this control characters. Now, if you know typing, we have a role thing which we bring it to the end, the beginning of the file line, and then it rotates by one line. So this carriage return is coming. This if you use the typewriter, okay. Let me try to mimic the typewriter. So you bring this as you type it, carriage moves it, and then we bring it back, and then it automatically rotates by one line. So line feed is feeding at one line, and carriage return is bringing the carriage. So Windows guys mimic the typewriter, okay, very systematically. For a line to line 1 I write, and then I write line 2. Between these ASCII characters and two carriages are put, line feed and carriage returns are put. Okay, it uses both CR and LF in the sequence. Whereas Unix and Linux, they only put LF. Okay, they would only line feed. Mac OS, they only put carriage returns, because we are not having a typewriter now. Okay, you can easily cursor can be brought to here. You don't need to give both the command. But Windows, I think they like the typewriter very much, and they continued with both the character returns, but they actually wasted two spaces. Okay, 2 byte. Okay, for where you could have used done only 1 byte. So that's why when you copy files across the file systems, you have some problems, because this is the unique way the files are stored. So now I am having a file text1.txt like this. Okay, when you read a line, it understands that it has to read one particular line, and then it prints the line. So that's all. And then I think rest of it I will copy it in the interest of time. I don't want to bore you guys. You may be knowing most of the things what I'm talking about. I already explained this line feed carriage return here. And then now I want to know the position of the file. Okay, there's a file pointer. Okay, when you're reading a file, as I mentioned to you, file is read as a sequence of bytes. So position, file pointer position tells you exactly where the file pointer is. Okay, that's why when you read a next line or a next character, it knows from where to read. So file pointer is moving across the file. If you have a line 1, and then like this it goes, it takes care of the two characters that you have. Okay, now let me see what is the file position after you read this. Okay, let me print it, and then we'll see the content and then understand it. Now where exactly this file is. Okay, maybe I will minimize it. So let us try to understand this. File position, it says 7. Okay, 7. File position is here 1.1. Here what it has read only one line, which is the line 1, and then the position is 7. Now let us try to count it. 1 2 3 4 5. 5 characters are there. Line 1, only 5 ASCII characters are there. Now where is the 7 coming from? Because when you try to read a line, when you say read line, what it is supposed to do is read the line completely and bring the cursor to the position where the next line is starting. So that means it has taken care of reading not only these 5 characters, it has also taken care of reading the 2 carriage return and line feed characters, which are stored by the Windows operating system while storing the line in the text file. So when I created this file and then stored it, it has included those carriage returns and line feed, and then you are getting it back because you are reading from the file system, which is a Windows file system. So the pointer is 7 now, and then going to read 10 characters. When I say 10 characters, I can read 10 characters. Then it reads 1, 2, 3, 4, 5, then 6, 7, which is carriage return and line feed, 8, 9, 10. Okay, now one thing, 5, 6, 7, 8, 9, 10. Okay, now let me show you this. You are reading 10 characters, 5 plus 4, 9, and then how does it say 10? Going to read 10 characters. Let me, I may make a mistake here. Okay, 1 second. Did I make any mistake? Okay, this is actually from pointer 0, 0 to 1, I think. Buff1, print buff1. Does it print? Yeah, it has printed line also, but I have 5 plus 4, 9. It shows only 1 as in between gap. Okay, I think it because position is 7 is correct. Okay, line 1, 5 plus 2 plus 6. Okay, 0, 1, 2, 3, 4, 5, 6, 7. That is correct. And then here, when you say 10, internally, I think that they take care of merging this. Okay, I'll tell you what happens is this is common across the different file systems, right? So they have because consistency. I think if you run it, I know not run it on a Linux system. Maybe I can do it. If I run it on a Linux system, also you will get the same content. I think. Okay, I need to verify it, but you guys can also do it. They wanted to remove that dependency of the OS because this is the OS agnostic and portable program, and the program should not give a different contents. Okay, when you read 10 characters here and you write a program, and then when you go to Linux port and it will read only LIN and E is left out, then you have a problem. Okay, so if you run this code on Linux, you may not get 7 there, you may get 6 there. Okay, because it only stores 1 character, but when you read 10 characters, it will read all of them. Okay, I will also check it. I have a WSL running. Okay, I can do it, but I don't want to waste your time. I will do that. Okay, it's a good exercise to verify. You can also do it and let me know. I will also do it. Okay, so it is uniform across, so it only assumes 1 character is stored between the file. Okay, that's why it is not only 1 character is left out instead of carriage return and line feed, and then it is showing you like this. Okay, it is reading 10 characters like this, it is skipping 1. Okay, I think so. I need to verify my explanation. Okay, I missed it when I tried it out earlier. Okay, now I am telling the position. Okay, again file to position is giving 18. Now I think then you can see 10 was here, 11, 12, 10 was here, 11, 12, 13, 14, 15, 16, 17, 18. It is actually positioning it here. Okay, where exactly you have read the file. Okay, and then when you do read lines, what happens next time is it is reading the lines in a text file, list. Okay, it brings it to the list, and then you get it into a list, all the lines. So you can see that it only puts 1 carriage return. Okay, it doesn't put 2 characters. So I think it is taken care of that. As I told you, it is only storing only 1 value there, 1 byte here. That's why you see that it is absorbed. Okay, even here only 1 line is 1 control character is put, carriage return. Okay, fine. Now let me not take too much time. Let me, any questions, please tell me. Okay, otherwise I'll go ahead. Now what is here? Now you are giving a relative path with a directory 1. Now in our current directory, we have a directory 1, and when I go to the current directory, directory 1, I have a new text 1. So it is going to open it. Okay, you have to make sure that you create the directory structure. Okay, I will zip it and give you, then only it will work, otherwise it will not work. So I am having a file called new text here, which is having this many contents. So it is reading all the lines. Read lines is a function which reads every line and then puts it into a list which contains every line content. Okay, so it gives you all the line as a list here. Okay, so very straightforward. And then you can seek a particular character. Let me explain it. Okay, now what does the seek do? Seek from 0. Okay, seek means positioning the pointer to the first position. Okay, and then it is like file pointer is moving back. Okay, and then it is moving to the next in the file, which is a new text file, this file, and then you are reading a line, so it reads the first line, and then I want to seek 10. Now, as I told you, 10 from there is it is here, one line is done. 5 plus 6, 7, 8, 9, 10. Okay, now when you read from the 10, E2 is printed. Okay, E3, sorry, E2 from here. Seek 0 and then seek 10 is moving the file pointer to 10 position, and then you get this E2, which is the next line in the file. Okay, let me explain, maybe if you are not understood. Your file pointer is here, and then it is going to the 10th position. It is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 is the position which is E. So the seek actually takes care of the carriage return line feed in the file. Okay, so it prints E2 here. So I expect maybe you can try it out yourself. Okay, and then understand it. Okay, and then you are reading a 4 characters. It reads E2, and then one, it is observing it as, after reading it, is leaving it as one file only, sorry, one character only. So 1, 2, 3, 4, it reads only 4. Okay, remember, when it is stored in the file system in Windows, it is storing as a carriage return and line feed, and when it is reading into the file or into the Python, it keeps only one character, and then when it writes back, it takes care of the, again, OS will take care of writing it. Okay, it doesn't even, Python doesn't even know. It will give it to the OS, and OS will replace it with carriage return and line feed. Okay, so this particular thing is replaced by OS while writing it back. So that's why you will get a consistency across. And then even if you are running it under different OSs, you will not have a difference. You will see the same behavior. It will read the same file. Okay, same content in Linux also. Okay, fine. I will read the remaining thing. I want you to try it out maybe at leisure. If not now, later on you can do it. You are closing the file here and opening a file again as an append mode. Okay, I just wanted to try append mode, and then I am saying 0, 2, and then write. Okay, it is like how many files are there? How many lines are there? 3 lines are there. So it is going by this is a number of lines. Okay, this is number of lines, and this is the position from the start. So 2 lines you are skipping. That is totally 3 lines you are skipping, and then you are writing the another line. So that's where the appending happens. So let me remove it, all this. Okay, okay, save it. Okay, now when I try to run it, so it has appended this particular line, another line. Okay, I should have put a carriage return there. 1 second, I will open it. So I should have put a carriage return here. Okay, then it will add a new line. Oh, okay, fine. Because do you think why it is asking for a new save? Because already this process is owning it, so it wants you to save it again. Okay, so that's the problem. Let us not do it. I'll cancel it. Okay, now you are reading the line, and then it is showing you this. Okay, let me close this so that unless I close this I need to close it. So let me close this. Okay, then you will not have that problem. two processors cannot access the same file. And okay, now it saves this because I have closed this file. Otherwise, this Python program was opening it and having access to that. That's why it did not allow me to save it here. Okay, now I closed it and I am able to save it here happily, no problem. Now I run it again. Okay, and then I will open it again. Okay, you see the another line is added. Okay, this appending is done because it keeps opening the file and then appends it to the next line. So that's what is happening. Append means I wanted to show you that it is appending to the end. So that's all. Let me complete everything. I'm already taking more time. Okay, let me show you. Okay, already I have done a close. Now I open it for read plus. Okay, read means you can read and write. Read plus. Okay, and then what did I do? Okay, I'm getting the status information about the file. Okay, you can always get the what are the different status and OS command you can run it, all those things. Okay, get OS get current working directory, and even I can open a new notepad. Okay, from the system. Okay, I wanted to just write out to you. You can open a new files, new application also. So from the Python you can open it notepad. Okay, now if I close it, then it will remaining things will happen, and then add a buffering while handling. So I can enable the buffering, and it's a small file, doesn't matter whether you are um, using the buffering or not, doesn't matter at all, but I just wanted to show you that. So this is the file, this is the name of the current file. Okay, this is the name of the current file. So I am opening this current file itself, this Python file itself. Okay, maybe I should print it. Okay, let me print it. Okay, 1 second. So I am printing that underscore file, which is this file name. Okay, session and anyway, this is the file name is there. Okay, so I am opening the name of the file. I am asking it to in the mode, what is the mode and name. Okay, I'm printing file name, same, this name and this is our same. Okay, and then I am closing it. Okay, mode, and then whether is it closed or not, I'm checking whether it is closed, because I just opened it, it is closed, is returning a false. And then default file size, I mentioned that it is 8K, so that's what. Okay, I think sorry, I have taken more time. I hope it was useful. Any questions from anyone? I hope I have not confused you a little bit. I don't know. Any questions? Okay. Okay, what I want you to do is maybe try it out on a Linux platform and to understand the subtle difference between the carriage return and line feed. Okay, it will be maybe it might come up in any of the interviews in case somebody wants to test you on this. Otherwise, it's a very straightforward file handling. Okay, so maybe I think we should have a break before I go into exception, or I'll ask you guys 10 minutes break. Is it okay? Or you want me to cover the remaining exception? I don't know. You are still thinking? Okay. Okay. So 23 to 33. Okay. Okay, thank you. Okay, 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 welcome back. Let us start. Okay, thank you. Um, I'm sure all of you are aware of exceptions. So let me start off. What are they? Now, um, let me follow this. There are at least two distinguishable kinds of errors: syntax errors and exceptions. Now, what are syntax errors? Suppose if you do for loop I range whatever, and then you forget to put the colon at the end, then it's a syntax error as far as Python is concerned. Exceptions are something which is runtime. That means while the program is executing, during the execution, the error happens, and this is called exception. Now, what are interrupts? Interrupts are something which is external to the uh, program. Maybe sleep time, if you say sleep 100 seconds, then the program is waiting for 100 seconds to be over, and the timer interrupt happens. CPU wakes up the particular task, OS, it wakes up the OS task, particular OS task, after the 100 seconds are over, and OS knows which task to wake it up, and your Python program wakes up and then starts running. So the sleep is kind of an interrupt, which is an external event which is maintaining the time and then giving you a interrupt to your program. Whereas exceptions are because of your own program going somewhere wrong, it could be created. Okay, the exception can be generated. Now, the exception as such is not coming inside the program. Okay, from inside of the program, it is actually during the execution it happens. So execution happens in the CPU, as I mentioned. Now, the execution could be due to some, maybe divide by zero error. Suppose if a divide by zero error, that means you are keep on doing some mathematical operations, and somewhere finally you landed up in such a situation that you are trying to divide something by something. This value happens to be zero when division happens. Now, where exactly this error is caught? Okay, it's not in the program. Okay, no, the Python program is not keeping track of what is the value of b when the a by b is divided. Finally, when it goes to, if it is a floating point or if it is an integer arithmetic, it doesn't matter. If it is a floating point processor will give an error. If it is an integer arithmetic, it's an integer divisor or ALU which is inside the CPU might give an error. So the exception happens by the CPU or FPU, floating point unit, is generated. Now the CPU or FPU generated exception is caught by the OS exception. OS is actually installing the exception handler. It will take care of capturing it, and then OS will know which code was running on the FPU when this error happened. If whether it is your Python code or maybe somebody else's C code, it knows, and then it interrupts that particular program and and says that exception has happened. Now, suppose in your Python code you have something a slash s comma by division by b and equal to c, then this particular line has created an exception. Now it cannot go further because it is 1 by 0 infinity, which is it cannot be written here, so it cannot be executed. The balance code cannot be executed, the remaining code after this. So now you have two options: either allow with this exception which is not even processed by you, or you are not even aware of that particular exception happening, then your program will be terminated. The whole program will be terminated. the process will be stopped and you will be notified that exception has happened. It will wake up from the place where it is. It may be deeper into the function call. Maybe F1 is calling F2, F2 is calling F3, and F3 is doing a division by some B, which resulted in an exception. Then it keeps coming back and then coming to the main program, which is your own Python program. Then it terminates and the process terminates, and you are getting to know that there is an exception in a particular location. So this is what is called the trace. It gives you the stack trace of the function calls, which function called which one, and then finally tells you where exactly the problem is. Now, if you don't want this not to happen, that unknowingly your entire program is stopped, but you are trying to say, I'm expecting something to maybe happening. Okay, maybe there may be some file error, or maybe some divide by zero error. It could happen in here in this location. Then I can say that I don't want the OS to keep, or the Python to come back to main program and stop the whole execution. I am willing to handle it internally into this, maybe the function, within the function I want to handle it. Then you have to specifically put an exception handler saying that div by zero, I'm interested in handling it. Maybe I will print saying that, okay, div by zero error happened, so return this from this function a value 0. Okay, that means, okay, if the 0 is returned, maybe I am willing to absorb the error and then go forward with my execution. I don't want the whole process to stop completely. And as long as your rest of your program doesn't depend on this result, and then whatever is returned is okay with the rest of the program. Okay, it depends on the correctness of this, because this you cannot just it's like when you have a wound in your body, you can't just put a plaster and then say that everything is all right. So you have to treat it. Otherwise, it will become a big problem later on. That's how this problem is also. If you are suppressing it, saying that I am going to handle the error, you better know how are you suppressing it. Whether further execution of the program or your rest of your code is going to be affected or not. You handle it. When you say I am handling the exception, you are going to handle the effect of this problem, and then not that you are hiding it. You know that this problem has happened, but you know how to handle it. Suppose when you have a wound in your hand, you know how to treat it. Maybe you will put a Dettol or Savlon or something and then treat it properly, and then you carry on with your work. So it's okay. But just hiding the fact that it is problem is there is not going to help you. So exception handling is not just hiding it, not suppressing it, but handling it properly so that the rest of the program works properly. Okay, so this is how the whole exception is transferred or transmitted or communicated to the rest of the program. If you don't do this, the special way of handling it, then what happens is the Python doesn't know what to do. So it will assume that maybe somebody else in the higher function may handle it. So it will pass this problem further up. Okay, the reason why it is not executing it further because it knows that this error is going to be catastrophic, and if you it doesn't know the value of c divided by b. When b is 0, then it has not returned any valid value into some a. In that case, it doesn't know what value to put here, so it cannot go further down and then say print a is there in your program. What will you print? So Python doesn't know what to do if this problem has happened and you are not handling it. It cannot handle it, so it decides to stop execution and then keep passing it back. It's like passing the bug to someone. Do you have anybody to handle? Do you have anybody to handle? So every function is going to ask the somebody up to say, do I have somebody to handle it? So this is how an exception is handled internally by most of the languages: Python, Java, C++, or any of this, even C. They do the same thing. Okay, but there is some minor differences between languages, but the philosophy is the same. So errors detected during execution are called exception. Exceptions come in different types, and type is printed as part of the message. So the different types of exceptions are zero division error, name error, type error. Suppose I will show you some examples. File error is also can happen. Suppose if you are trying to open a file which doesn't exist, there's an exception. OS doesn't know what to do. it says that I don't find the file. Now your program expects to open the file and then assign it to some text or one or something, and then you are going to do seek. Now how can you seek when you don't even have a file opened? So it cannot go further, so it is going to give an exception saying that file open error. So this kind of things needs to be handled always if your program is supposed to be sturdy and production ready, or very safe program. So there are standard exception names, built-in identifiers. You can know there are known errors. But suppose you have an object, and then in your object, suppose you have an object, you have a cost variable, and you don't expect this cost variable to be 0 when you are processing some in your somewhere in your file or somewhere in your program. You don't expect the cost to be 0. Okay, it is not a error as far as the OS is concerned, because cost variable can be a 0, but your application needs the cost should not be 0. Maybe later on down the line you may be dividing this cost with something else to know the profit or something. So you want to capture this error. When by mistake cost becomes 0, I want to capture the error. Then you need to have an exception, user defined exception or something. It's not due to division or error, but due to some input error. Maybe file is given an input which happens to have a 0 value, which is not correct. So you can also capture your own errors which are specific to a particular data or particular application. Then you can add your own exceptions also. Okay, I'll tell you how to do that. So there can be user defined exceptions too, which need to be derived from the built-in class. So there is a class called exception class. So you cannot arbitrarily say my class is exception. You need to derive it from exception class. Then only if the exception happens, the Python knows how to handle it, because exception needs to be handled in a different way by the Python programming language. So it needs to have this exception as a base class from where you have to derive your own user defined exceptions. So this is a way exceptions are defined. Handling the exception, it is possible to write a program that handles selected exceptions. Like this is how you do. Now enter a number. I enter a number and then I do a break. That means I come out of try. Then now I'm saying value error. If the value is wrong, then I want to create a value error. Okay, so I will tell you what is mean that. Okay, this code is a sample code. I don't think it depends on what value you are giving. Now let me explain. You are taking an input from here. Now this input is an integer object. You want to convert this into an integer object. So now if I give a value called 12 or 34 or 55, no problem. It's a valid number which can be converted into integer and put into X. But if I give AA or a string which is not a number, then you cannot convert it into integer object. So it will be a value error. Okay, that was not a valid number. So try again. So if you are, especially when you are getting a user input, you can put an exception handling. So now when will this break executed? It will be executed only when there is no exception here. Exception from this conversion. Okay, when you are giving a valid number here, integer will be converted. It will be converted to an integer. It will be assigned to the variable X. Then it will break from here. It's a normal flow. Normal flow when input is a valid integer. Okay, but in case if I don't give a valid integer, I give some AA, then it cannot be converted into integer. Then this particular library, this int library, creates an exception. What exception? It is creating a value error exception, because the value what it got is not valid, because it is expecting an integer value to be given, but you are giving something else. Now what happens? This X is not assigned. X is not assigned a valid value. Break is not executed. So since you have put an exception class and then you are looking for a value error and you are willing to handle it, control will come here. When you give a invalid number, it is not executed, X is not assigned, break is not executed, so it will not come down, it comes here. Now you can execute this, it will print this, and then you can decide to come down. Okay, it's not that you cannot come down at all, it depends on what you want to do. If you are willing to be with the X value which is not correct, it's okay. But if you are willing as a while to, I forgot, it will break from the while loop. Okay, when you are saying while. So let me summarize it again. What happens is, if you give a valid number, it will be assigned, it will break from this while loop and then comes and executes this. If you do not give a valid number, this function generates an exception, which is a value error exception, and it looks for within the try block, because you have put a try block, then it knows that you are willing to handle it. Then it looks for whether you are handling the exception which has been raised here, because the value error came and you are saying that if a value error happens, I am willing to handle it. But if some other error happen, it will not be willing to handle it. So only if value error happens, it will print it, and then it will continue in the while loop. It will not break down. So it will again ask you, please enter a valid number, because you are given an invalid number, try again. So it continues, it doesn't come down, but it depends on what you want to do. You can also put a break here by replacing the X value with some 0 and go down. You are not saying that, I'm not saying that you should always put a while loop, because sometimes user will be annoyed when you keep asking them. Okay, you can say that in invalid numbers, I am taking the value as 0 and going forward. Also, you can do. It depends on what you want to do. Okay, so this is how exceptions are handled. If an exception occurs which does not match the exception name, suppose this is the named exception, whatever exception is happening here, if it is not matching with this, it is passed on to the outer try statement. That means it knows that this try statement is not willing to handle it, or it doesn't know how to handle it, so it will be passed further up. That means it may come out of the while loop and look for a try. You can have a while try within a while loop, or if it is a function, then it will come out of the function and look for a try. Okay, it will keep on going up and in the value, the tracks stack trace, and then if you don't have any try at all, which is matching with the error which has happened, the exception which has happened, finally it will stop the whole program and then comes to you saying that I cannot handle it, or you did not have anything to handle it, so I am giving it up. So Python doesn't know what to do, so it is going to terminate your program. So that's what will happen. So if no handler is found, it is unhandled exception, and the execution stops with a message as shown above. Okay. It's a normal. Unhandled means it will be completely gone. Okay. A try statement may have more than one except class. You can have more than one except class. The value error is this. I can say except something and then I handle it, except something I handle it. So it is like a switch case statement in C. You can have multiple except statement where it might try to match it with one of the exceptions that you are willing to handle. At most one handler will be executed. So remember that if you are having multiple exception handlers, it will be only one of them will be handled, not multiple. It's not that it will try doing this like a in a case one, you do something and you forget to put a break, then case two it will also fall through, right? If you put a break in C language, that way it is not there. Okay, it doesn't look for a break or something. So our Python Guido decided that whether you have a break or not, he will not execute more than one except case, not like a case where you forget the break, it will fall through. That kind of a thing is not there in this. But he has removed all the programmatic error which are likely to happen. So language is very sleek and strict. Okay, it doesn't expect the opportunity for errors are minimized in the Python, because you may forget to put a break without knowing that it will fall through. So that kind of thing is not there. Okay, you don't need to put a break like a case statement. So at most one handler will be executed. Okay, handlers only handle exceptions that occur in the corresponding try class. Okay, not in other handlers of the same try statement. So what I'm trying to tell you is, suppose you have a try and then a program. Okay, and then except. E1, suppose E1 is on exception type, some code except, okay, colon is there, try is also colon is there, except E2, okay, some code is there. Now this E1 handling and E2 handling is for any exception happening here in this part of the code. Please remember, any part of the Python code can create an exception. Even your own exception handler can create an exception. Suppose, I'll give an example. You have written a code, whenever exception happens, I want to capture it in a file. So I will open a file in a read mode, okay? And then I will put this message inside the file. You decided to do like that. But now what happens? This file doesn't exist in this place, in the directory wherever or whatever path I told you. Then what will happen? This is going to create an error. Now this itself is going to raise an error exception, okay? This code is going to create a file exception, file error or whatever. Now you may have an exception except E2 which is file error, okay? File error, suppose, which is meant for any file opening in this piece of the part of the code, not for this piece of part of the code. That is what I am saying. Handlers only handle exceptions that occur in the corresponding try class. This handler and this handler is willing to handle the exceptions handling, being raised in this try class, not in other handlers of the same try statement, not in this statement or maybe in this statement which is equivalent to this exception. No, that means you need to have a try here and then do it. So the lesson learned is, do not do something, okay, which will cause another exception from the exception handler, okay? It is like this: when someone is injured, you are supposed to do something to the injured person which will make the person better. Not that suppose somebody is fractured the leg or something, you try to go do a first aid and then handle it badly, that you create some more fractures to the person than handling the person properly and taking him to the hospital without disturbing the leg. So that is similar to this, okay? Do not do anything very catastrophic here in the exception handler itself, which will cause another exception which will not be caught by anybody. Even your own exception handler which is nearby cannot find it, and it will come out and your whole program will stop. So you need to be very careful where the exceptions are happening and who is handling it, who is responsible to handle it, okay? I hope this is clear. Okay, sorry, I don't know why. Okay, no problem. I don't want to do it. Let me show you. Let us read it one by one. Following code snippet shows the generic structure of exception handling. Some code which you suspect that can create an exception. Okay, you are suspecting. Then that kind of exceptions you need to put it here. Okay. Optional block, you can have something. Handling of exception is required to, you can just print it and then forget it, but you do something, okay? Do some first aid and then try to handle it. And then you can also, this can be any number I told you, except E1. Okay, you can put E1 multiple things here. For all this kind of exception, I do only one treatment, okay? Like for all the corona, either Delta variant or Delta 2 variant, you take the vaccination and hope that, your corona will be rectified. So that's like multiple corona instances, but you do only one vaccination to take care of it. You also have different exception classes. You can handle it differently. Now, else class, this is something you execute it after. It's like if you want to celebrate it. Suppose so many exams are there, okay? Every exam, E1, E2 exams are there. You put an except class for every exam. If it goes, if bombs, then you handle it in a different way. And with God willing, and you are prepared well, all exams go well. Then you come to the else condition and celebrate, go to party, okay? Celebrate. That is a else condition. When you are successful in all the try conditions, that means none of the exceptions happen. Then you come to else condition and celebrate here, okay? Now what is finally, that is either you get an exception, you go into some of this problem, or you successfully completed everything, you came here, okay, you do finally. That means every day anyway you are going to sleep, whether you in between you go for a party and then sleep, or you take care of the handling of the exception and then sleep. Sleeping is going to be there at the end of the day, so finally is kind of a ending the day with sleep. So you either you complete everything or you get into exception, you handle it, and then finally is executed. This else may not be executed, okay, it depends on it. This else is executed only when everything was good and no exception happened. But if any exceptions happen, you handle it and then come here and finally do something and then go down. Okay, that's what is the generic structure of this exception class. Nothing more. That's all. If you understand this, I think the my code I will execute. I will show you quickly, and you will be able to understand it. If an exception occurs during the execution of try class, the rest of the class is skipped. Okay, class is skipped. Please, class. It's not class. I may pronounce it wrongly. If an exception occurs during a execution of a try class, the rest of the class is skipped. Okay, rest of the class means this itself is considered to be a class. Multiple statements. This is a try class. Okay, and then exception happened when you executed this instruction. Okay, this will not be executed. That's what I mean by rest of the class. Okay, this will not be, even if you have something else in the try class. Okay, everything is inside, it will not be executed. If you handle the exception, it writes the exception E1, it will, if you have put a handler, then it will be executed. Now what if I don't have it? Then okay, you don't have it. Now this has to be raised up. Okay, it has to go further down. Okay, then I think finally will be handled and then go up. Okay, let me check it. Okay, in the next section. So it will be passed on to the top. Okay, exception is not forgotten. Okay, it has to be either handled or it will be passed up to the somebody to handle it. Okay, so this is what happens. Then if its type matches, okay, if suppose you have put a handler for that exception, the exception named after the except keyword, the except class is executed, and then the execution continues after the try except block. Okay, so exception will be handled, and then it will be either finally is there, then it will be handled. If you not put a finally at all, then it will go down and then start executing the remaining thing. So you need to take care that the rest of the code that you execute does not depend on the exception that has happened. So that means if you are continuing with your travel with your leg injured or hand, so not you, somebody else is handling, somebody is continuing the travel, they need to make sure that they handle the injuries well. They can travel further without much of getting into problem. So that's why when you are going further in your execution, you need to have already taken care of in this case that none of this execution will cause another exception. Okay, possible exception. So that needs to be taken care of. Okay, otherwise you are not doing a proper handling of exception. Fine. Now what is finally block? Okay, it's a little lot involved. So before I go into this, maybe I will show you some example, because finally is more involved. So let me close this classes except class. So anybody, any questions from anyone before I go further on whatever I explained? Okay, you guys are already mentally prepared to expecting me to stop early, so I will do it, don't worry. So let me take something. I don't know how much to take. Okay, let me take everything. I think I should take everything. Okay, now you need to have this trace back, because if it has to give you the information, you need to have this trace back to be imported. Okay, import module. Now I have written some function. Okay, what is that some function? inside some function, and it is trying to read a file which doesn't exist. Okay, no file. That means whichever directory I am, pwd cls, cls directory, let me go there. I don't have that no file dot text here. Okay, so I will enable it when I want it. Okay, I kept it under comment. Okay, now I have a function fn which calls fn1. I put inside function and then end of function. I want to show you that the control, if an exception happens, it doesn't execute further down. Okay, that's what I want to show you. That's why I'm printing the end of function everywhere. Okay, this is some function fn calling fn1. What is in fn1? I print this inside fn1. I try. I do it. I am willing to capture the exception now. fn2. When I'm calling fn2. Now, what is fn2? I am coming down. Okay, let us see. Now, what error I am capturing? I am capturing OS error. Some OS error. Okay, that means it has come from the operating system. OS error is handled in this function, and the details of the error, I can get the details of the error. Now, this error is a type. Okay, remember this is a type of the error. When will this control come here? Only when whatever I execute here, fn2, need not be inside fn2. fn2 is calling some function is calling something. So if the error happens here also, I have not put any try or exception here, so it will be passed up from the sum function. So sum function will come here and it will pass back to fn2 because it is not handled here. It will not come down. It will keep going up and up. Okay, because it is trying to find out who is willing to handle my error. So it will wake up fn2. It will wake up here and it will carry the error. Where is that error coming? It's a exception object. Exception object with a type saying OS error has happened is come here. Now this control also, if I put something below some printf, it will not execute. Okay, after this, if I put a print, it will not execute. I have not put it here. It will look for the error handling if it is there. With the type of error that I am getting, is there anything willing to handle it? Now it will find that OS error has happened, and that object which came from inside of the f1 some function is available now, and that is what I am taking it here. OS error as instant. Okay, I'm just giving a label to it. That object which came from fn2, if there was an exception, it will be assigned here, and I can get the details of it by printing it here. Okay, printing it here. Okay, I will come to this later. I can print it here. Then what I'm doing is I am raising the exception again. Okay, let me explain this. I have put intentionally, though I may say that I have handled everything here and then I can just keep quiet, but I am raising the error. Now this is what is called false alarm. Suppose you may know that the fire alarms, really fire happens and then you raise an alarm, but sometimes they do a mock drill. They switch on the alarm and then create a mock drill so that how people react. So this raising the exception is like that, similar to that. You are actually, this error has not happened here. It happened inside the sum function trying to open a file, but you have that error with you as an object which is of type OS error only. You are using that instant and then creating the OS error here. Okay, you are building an object of OS error type exception and raising it here. Now why are you raising it? I am just wanting to test it. So within the exception handler, I am raising another exception. Remember, it is similar to what I have said, that exception handler can also raise an exception, right? By mistake or by intent. Here I am doing it by intent. So what will happen here? Now, as I told you, this error will not be handled by this exception, because this exception handler, whatever you have put here, is meant for exception happening in the try class, not within the exception class. So this will not be handled internally. Then if it is handling it, it will be an infinite loop. Okay. So, and it's actually illegal to do that. So it will come out of fn1. Okay, this exception is coming out of fn1. This will also not be printed. Okay, it is coming out now of fn1. Now who is calling fn1? Fn1 is called by fn. Okay, now fn1 is waking up now because of this exception happening here. So when it happens, fn1, around fn1 there is no try class, so it will not execute this. It will pass back out. Okay, I don't care, I don't know how to do it, so it will pass it to out. It will come out of fn now. So please remember, it is a trace back. That's what I am doing it now. So finally, F1 is called by this function here. I have handled it, and it will come out of here. Okay, so that is how this flow is happening. Okay, since I started off from here, I am going to explain this fully and then finish it. Then we'll do other things. Now let me do this. Okay, F1. Now let us trace back ourselves one by one and then try to see what happens. Okay, now these are all functions. Okay, I explained you what are the functions are there. So when your main program is executing, it is executing this first, learn about exceptions, and then immediately I'm going to try print before exception event. So forget about all the command. I am calling fn. You went through the function sequence. So f1 is here, it is calling fn1. F1 is here, it is calling fn2. F1 into here, it is calling some function. Okay, now some function is here. I have commented off this. Okay, let us retain it as a commented only. So no exception is raised here, no file is not going to be used, open is not done. So it completes properly. Print end of some function will complete properly, and then it will print everything. All of them will never get into any exception, and it will print this also properly, and then come out safe. Okay, it should come out safe. Now let us see, first of all, without opening the file. Okay, without opening the file, which is the root cause of file error, I want to run the whole code to see the flow of the code. Okay, let me execute it. Now that's the first thing we should do. Okay, now let me see inside f1, inside fn1, fn2, some function. It end of some function is executed. Very good, because I did not open the file, so no error. Then end of function 2 came, mapping. Okay, matching function 2. Then end of function 1 came, which is matching with this. And then end of function n came, which is matching with this. And then after the exception event, which is here after the exception event, now what happened? It has come out of this execution without any exception. Now will it go here? No. Will it go here? No. Will it go? No. No. Here also it's a default exception. Any of the exceptions are not handled, it's like a default in case switch statement is a default. Any other exception which is not one of them will come here. Okay, now else condition. Now this will be executed because everything went fine, right? Parting is required, so all fine, no errors, parting happens here. Then you have to sleep at the end of the day, so leaving the except class also happens, then come out. So this is the normal flow. Now let us uncomment this. Okay, now what will happen? You should mentally execute it to know what would happen, so that we can map it with what you get it. So let us trace back. F1 is going to call F1, that is going to call F12, some function. This much is going to happen. Okay, all these 4 will happen. Now you are inside the sum function. Okay, you are trying to open a file which doesn't exist. It is going to write an exception. Then it is not handled here. That means it has to go out. Then it is not going to execute this. So you are not going to get this. Okay, sorry, you are not going to get this. Now it comes out of the sum function. Where will it come out? It will come out here. Now it is not handled here also, so it has to go out. Okay, it's like when you are in a 3rd floor in a room number 23, inside a room number 3, when fire alarm happens, you run out of 3, you come out of 21, you come out of third floor, second floor, ground floor. That's all. You don't go and inside the room, you don't do something. So you are here, but you are not supposed to come further down and do something. You are supposed to just go out. So F12, it comes out. So this is also not going to be executed. F12 wakes up where? It will wake up here. Now OS error has happened, okay, and you are interested in handling it. You have put a handler there, so it is going to execute this. It is going to execute this, but unfortunately, you are not stopping with the alarm. You are still raising the alarm. Same error alarm you are raising. So it is not going to be handled by this. It's a new error. Okay, it's a new error. What you came from that, what you got from there is handled here, but unfortunately you are not handling it fully. You want somebody else to handle it, so you are passing this object again further and run raising the alarm. So it comes out of fn1. Now it will, fn1 will wake up here, so it is not going to execute this guy. So even this is not going to be executed. Okay, now it will wake up from fn. Fn is here, it will wake up here. Now it is not going to execute this because you got an exception. Now it will look for OS error here. Yeah, luckily you have another OS error handling. So what you do, you will get this to print out. Okay, again it is getting printed, but you are not raising it again. If you keep raising it, then what is the point in handling it, right? Hopefully you should handle it somewhere. So you are happy that you are handling it. So you are not going to raise it, but I want you to uncomment it and check what will happen. Okay, I want you to expect it what to happen. Okay, now you know that it will handle this. It will print these two, then it will not print this at all. Okay, and it will not print any of this because you have specific exception you handled, so it will not come here, but it will come to the finally, because end of the day it will sleeps. That's all will happen. So let us run it now. As I mentioned, up to some function, everything going fine. Then you are handling the two errors inside this fn1. So inside fn1, you handled it, but unfortunately, you raised the error again, exception. So it came down, and then it did not execute this. Okay, but it came to OS error, and in the main, it printed this. Okay, now what is this print? This is the print of this one. Okay, uh, details of the error. Okay, details of the error, what is inside the instant object. You can see that it says error 2, some specific error 2, file not found, no file or directory. Okay, because it doesn't know. OS came up with an error. Maybe if you are given a path like this, I told you slash Mauri slash some directory, you can get a error anywhere in the path, or you can get a error in the final file name. So both are handled the same way from the OS itself, because it's not able to open the file. It may be because the file is not existing, or it may be because one of the directory path along the file is not existing. So it will give a no such file or directory error, and it will give you the path which created it. Now this is the path. It's a relative path of only file name, so it prints that path. So you see this, it also prints this. It is having that information. Okay, which file caused the file error. It is within that object. It is within this object. That's a beauty. Okay, what you gave it to the OS came back and gave it to you, which file name. Okay, you did not get it from anywhere else. You just, file you opened here with this file name, you did not save it anywhere. You are suddenly finding it in the instant object, which means that the file which went inside the OS call is coming back to you again in the object. Okay, because OS is passing it back to the program. You asked me to open this file, I did not find it, please do whatever you want. So that file name is coming. Not only file name, the complete path name will come, whatever you gave. Since you gave only this much, it came back only this much. Okay, so it prints that error. Okay, that is the crux of the information that is stored here. Now what is printed? This is leaving the class except class. Okay, hi, bye bye, saying bye bye here. Okay, and then comes out. This is the flow. Is there any doubt in this understanding of this, anybody? Okay, I hope it is clear. Then rest of it is simple. Okay, this is the most complex thing which I happen to explain it. Now you can relax. You can have your dinner parallelly. Now what I am going to do, I am going to comment off this guy which is done. So I am going to raise a divide by zero error. Okay, so let me clear this guy. Okay, only one you enable because that is better. Now I am running it. What happens? I did that divide by error. It went to the ALU, got divided. I presume so, but some optimization could be done by the Python language that anyway, if I send it to the CPU, it may not be completed and it may generate internally. I don't know any optimization is done or not, but in a real life scenario, it would have gone to the CPU and executed because here you are giving zero clearly, okay? But if you are given a variable name, Python doesn't have any way of finding out what is the value of that during the execution, okay? In this case, it knows you are trying to divide by zero. Python itself will know that there is no point in asking the zero to be divided by a CPU and then getting the error back. So it may do some optimization here, but in a real life scenario, if you put a variable name, it will not know the name, because it is executing runtime. So it will be caught only in the runtime. So here I am not saying that it is going to be runtime, but still assume that it happens. Now what happens? It is not going to print this. It is not printed it. It will immediately go to the divide zero division error. So where is it? It is printing here. Okay, this is not printed before exception event came, and then divide by zero error happened, and then what happens? It prints here. Then this is in the try block. Oh, no, sorry, it doesn't print here. Okay, this is not printed. That's what I wanted to say. So error has happened, and it comes to the zero division error. This is printed, which is here. It is printing the instant now. What is inside that? Division by zero. It doesn't show you the value or variable or something because it is not a variable. It's a constant. So it doesn't know what to show. So it shows you the division by zero error. And then what does it do? Okay, let us see. Zero division error. Trace back, print executable. Okay. This I am intentionally doing it. That's why I have put an import. Otherwise, nothing else is required. Because I'm using this, I imported the trace back. Let me tell you, that is what is printing this traceback call. Okay, what has caused this problem? Okay, which exactly what equation or what exactly caused this issue is printed here. When you say traceback print exe, okay, you can try out. This is a very good mechanism to know exactly which part of your code is causing the problem. Suppose if there are too many inner loops and then somewhere else you are capturing it, this will tell you where exactly this error has happened. Even if it is not in one level, it can be multiple level down. You will get the whole trace back information. So that's why you need to import this trace back and then print it. Okay, otherwise also the interpreter gives you, but this may be giving you some more additional information. Okay, then what happens is you are printing it here, then it finally prints the finally. Okay, where is it? Sorry. Finally is not printed here. When you do this, it is not printing the finally at all. Okay, so let me comment off. I'll show you. Okay, yeah. So if you do this, you are not getting that. Okay, it prints that and then comes out. Okay, finally is also not executed, I think. Oh, it is printing it here. I don't know. Oh, it prints it. I'll tell you what happening is after this. I did not pay attention to that when I ran it earlier. See, this leaving X class is printed and then this traceback is printed. That is the whatever this traceback value. So it prints after the finally is executed. Okay, you can try it out yourself. Okay, now let me go try out other things before I stop it. Okay. Okay, this is only, it never printed, so there is no point in having this. This is what type of error do you think? You are trying to divide a one by a string, okay? A string object, okay? This is a string object. Don't expect this to be converted into an integer automatically unless you put a int here, str to int or whatever, that it will not handle it. Okay, int will handle it, but you if you give a string object, it cannot divide it, so it will give a error. So what error would you think will give? Value error or type error? Okay, you can make a guess. I will show you what will happen.
So type error.
Okay, sorry, I did not wait for you. Thank you. You are right. So the data type that is getting divided is wrong. So you have guessed it right. Value error is it is specific to a value. So that is after you interpret the value. Here the type itself is mismatching. It doesn't even know the value of it. So it expects another integer to be there. Sorry, it's a single division, so it should be a float. It will be a float division. It is expecting a float division, or automatically it will be converted into a float even if you give an integer. But it's no longer, the string is not a valid type. So it's not even possible for it to convert it into an integer and then to float. So it is going to give a type error. Okay, so what happens? Type error has happened. Details of the error is saying that unsupported operand type. Okay, you are given str, okay, or int and str. Okay, you are given for slash, you are supposed to give a float, but you are given any of this. Okay, it says that you are given something wrong. The type is wrong. Okay, so it gives you that information because they might have put a common message for any of these kind of different errors. That's why you will see multiple things appearing. Like even OS has the same kind of message, not able to open a file or a directory. Okay, they have put a single message for both, not able to open a directory or not able to open a file. So they want to optimize it. So implementation. So this is what has happened. So very good. So type error is happened. Now let us look at no file. I think we already handled it, but I handled it inside a function. Now I am trying to create it here. So let us see what is the difference between these two, so that you know how traceback works. So the error has happened here itself. So it comes out. I have put OS error. Okay, it comes under OS error. Then OS error happened. Details of the error. The same message what you got is coming here, and then leaving the except class. So now, since I did not execute this this statement, it always execute the finally class and comes out. Okay, it doesn't execute before. Okay, this is done. Then what about this? Input give some integer value. Okay, now is it integer a while? No. So I'm going to give one integer value. Okay, and then I'm going to see whether which is creating a problem. Okay, which is causing a problem. So let us try running it. Oh, you know how to do it. I'm going to give an input. So let us be good guys. So let us give a valid number. All fine, no errors, leaving the except class, nothing, no problem. Okay, now let me run it again, but this time I am going to be little cranky. So let me go with something. Okay, now I gave a wrong value. So value error came. This is a value error. It's not a type error. Okay, because I'll tell you why value error. Where is it actually happening? Here. So this integer converter, the integer constructor expects a value which is an input, okay, which is happens to be a string with the EE, which cannot be converted into a proper integer. So it tries to convert it and then fails it, and then gives this is raising an error saying that it's a value error. So that's why you don't get this printout coming, and then value error is caught. Value error happened. Details of the error says that this particular value which you gave me, which is supposed to be a base 10, but something else has come. I'm sorry. So that is the error coming from the Python library. And then a non-integer was given. Okay. You can see that a lot of message is there. Okay. Where is the what are the details of the error is? All of them are not printed by me. It is printed by what has come from the inst. Okay. non-integer was given, invalid literal for int with the base 10 EE. Okay, this error happened, and then the finally class is executed and goes out. Okay, that's how things happen. I hope it is clear. Now finally one more, give some character other than an integer. Okay, why did I do that? Okay, I don't know what I'm doing. Okay, same thing. It doesn't matter. I don't think I should do it. Oh, maybe I'm trying to use it here and then no. It will not execute at all. So I don't think I need to use this. Okay, that's all. It's I think you have understood the execution here. I don't think I need to do anything more. Give me 10 minutes. I will be done. Okay, I have something more to show you. Okay. I think you may be thinking that everything is over. I'm sorry. Even I felt that it was over. But okay, now I have a not exception class. Not exception class. That means I'm just having a class, okay, which doesn't have anything. Now I am trying to explain you raising an exception. Okay, let me. Where is it? Okay, let me tell you what I'm trying to do. Okay, now I have created a class. I created an object. Okay, now I have put a try block. I want to raise an exception, my own exception. Okay, I want to show you this is not inherited from exception object. So I can't raise whatever I want. Okay, raise an exception because the later part of the handling is handled by the Python library, and if it doesn't have the exception object, then it doesn't know how to handle that object. So it won't allow you to raise any type of object as an exception. So if I execute it, it is going to give me an exception. Okay, illegal. Okay, I cannot raise an exception object. I cannot raise an exception with an object which is not derived from an exception. Okay, I hope you understood. So then this itself is creating an exception. Okay, where is it going? Illegal rising of exception. That is a message. Okay, exception parameters are given below. Well, as I am printing it here. Okay, so it is caught here. Okay, this error is caught here. Okay, let me come out of this. I want to show that. Okay, I have the same thing. Same object. Okay, let me comment out where exactly is happening. Okay, so it is happening here. Now I can also do it here anywhere in this. Okay, so not a problem. Now let me comment off this. Okay, this also I'll comment off. Now what I'm doing, type error. I'm creating a type error. Okay, this is a valid object type. Okay, this I'm creating it here with some 420. Okay, number was chosen intentionally. Now you see here, I can raise a exception with a particular object. I can create an exception object of type error. Here I raise it and I immediately catch it, and then it really catches it and then comes here. Okay, so that's what is shown here, and this is just a show. Okay, okay, I want to comment up. This is actually is a message only. It's not a execution. So what I'm trying to tell you is, when you are printing it, this instance class has implemented this string built-in function. That's why you are getting all this printing. Okay, because it's an object, so it is implementing this method. That's why you are getting all this printout coming out. Okay, so fine. That's all I wanted to show you. Now I am going to show you finally one thing before I stop the exception class. I think it is good to know this. Okay, I don't know how much time I have. Okay, now I am showing you creating an class A, inheriting from exception, and B inheriting from A, C inheriting from B, and D inheriting from C. Okay, that means what? All these classes, the parent is exception. That means what? I can raise a exception of this. Okay, raise D, object of type D, object of type C. I can raise it because internally they are all derived from exception class. So they can be raised as an exception. Okay, these objects can be raised as an exception. That's all I am trying to tell you. Now let us try to use it now. Okay, one by one. Okay, now you can make a guess. Okay, any of you. This explains the order of checking the except class. Okay, I want to try to explain you how the order of except class means the exception classes, how they are checked. Okay, I have D, C, B, A. Okay, so let me explain. When you have a exception here, like a case statement, actually case statement is not in the same order. Okay, it will be a direct jump to particular case statement in C. Okay, it will do a compare and then it may jump to the direct thing. But here our Guido, our friend, implemented it in a very clear way. That means there is no ambiguity here. He says that it will be tested, whatever exception is raised in the try block, try class, is going to be tested against the exceptions in the same order you have given it. That means if something is raised here, it will check whether it falls under this category. If it is true, it will come here, and rest of it is not executed, it will come out. If it is not this type of exception, it will check here, then here, then here. So it is like a AND condition. Only when it is false, it will be checked, the remaining AND condition will be checked. So here also, only when this is false, this exception class is not of type D, it cannot be categorized as a class type D, then it will be going and checking this. Now what I am doing, I am keeping these class objects. Please remember, they are all class also can be an object, remember. So I am keeping ABCD, not an object of type class. They are all the different classes. So that's why I use the CLS here to give us the mind in our mind that they are all class objects. Okay, very funny to say class objects. Okay, class instances or whatever. Now when A is come, okay, A is raised. When A is raised, it's in the for loop. Okay, so we are going to be raising it one after the other, and one of the except class is going to be executing it. Okay, so it is going to be in the for loop. Remember, it's not break is not given anywhere, so it's not breaking out of the for loop. So after the except class is completed, it is no finally class is there, no else class is there, it will come to the again for loop. So what do you expect the output to be? What do you expect the output to be in this case? Anybody can tell? If you are writing it in a chat window, I need to go there. Okay, I need to show you the hierarchy also, right? A is inside B, B is inside C, C is inside D. Okay. Now I am getting the CLS as A and raising it. I can raise it. There is no going to be no exception raised because of that. Okay. I am properly raising the classes which are inherited from exception objects. So they are all valid raise instructions. So this instruction is valid for all ABCD. If I put some other object which is not derived from exception, then it's different case. Okay. So my question is, when a type A exception is raised, do you expect a D to have, should it land here or here or here or here?
Sir, or at A only.
Okay, what about this?
Sir, B.
Okay, so what do you
Because
expect?
because B is coming before A. If the order of the list will get reversed, like if I am supposed to check D first, then every time it will give A.
Very good, you are right. So let me show you the output. So what is happening? Let me tell you. Okay, though she has explained, whatever you are looking for, okay, should be a uh, super class or whatever. Okay, it should be completely satisfied. Okay, let me tell you this way, not a super class. It should be completely satisfied. Now, if suppose you may think that okay, A anyway is inside the D also, right? A is inside B, then D, but it is expected to only say when D is raised. Okay, now when A comes along with that, there are so many other objects are also within. It's not equal. Okay, so this will not catch it. Okay, like what she said, if it is in the reverse order, it will catch it. But let us see one by one. Right now, it will come down to A and get printed. When B comes, it will come down, it will check any of the exception. Please remember, it will only check the exceptions but not execute any of them. Okay, it is checking this, checking this, checking this, and then print B. Then when C comes, it checks this, it comes inside, print C. When D comes, it is raised here, it checks this, it comes inside and prints it. Then nothing else is there, so it come out. Okay, that's all. Okay, ABCD is the right thing. Very good. Now let me ask what happens here. I hope you remember the inheritance path. So as she mentioned, the sequence matters. So one second. Yeah, you tell me what you expect the printout to be.
So A, then again it can be A.
Okay.
A only, sir, because the A is the base class, it can go up.
Okay. So what is your final answer? How many A's?
4 A's.
Anybody objecting her giving some other input output? Okay. Let us presume Swati. No, it is. It was. One second. Yeah, Swati. So let me execute it. Very good. All A's. Now, whatever may be the class, A is this is fully inside. Okay, this is I can see the complete A object inside any of them. Okay, because A is the, as she mentioned, that was the top of all. So A comes there. Okay, A prints it. Now what about D? Now D, when B comes, that is all this BCD, they don't come here at all. This is not tested at all. All of them get caught here because every one of them having that A in them and it exactly matches. So just to easy to remember, crude way, what I am looking for should be inside it completely. Okay, then I am happy. Okay, A is inside this, A is inside this also, everywhere A is inside, so I can, it will be caught here only. Doesn't matter whatever I give here, it doesn't matter at all. So as she mentioned, AA will be the output. Very good. That's why I put this at the end so that you don't see it. Okay, I'm very very bad guy. Okay, now anybody wants to go for it, or Swati also can go for it.
So A, then B, then A, and A. No, B. Sir,
Mhm.
excuse me, sir.
No problem. Even I forgot. Yeah, tell me.
Sir, A, then B, B, so B.
Okay. I thought you will give some music band. Abba is a music band. No, I don't know. Okay. ABBA or something. Okay, fine. Now I don't want to test my memory. Very good. You are on dot. Maybe you can explain better than me. Okay. So the same
No, sir,
logic.
it is not like that.
No, 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 no. Hey, it's okay. You don't think that you cannot. Okay, you can explain. Okay, so it is a good thing. Okay, you are right, and I think same logic if you use, I think it is easy. Now, what are we doing? A is raised. It's no completely B doesn't match with A, right? So next, when it is matched in this, so A comes. Then the rest of the guys are all inside. B is inside any of them. So A, B, 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 three Bs. Okay, not too many Bs. Is the correct answer. Very good. Thanks. So I think one more maybe. I don't know. Oh, okay. I hope I'm not showing the answer. Okay. Finally, I think. Um, tell me. Same logic.
Sir, A, C, C.
Okay. I don't remember. Okay, let me see. Yeah, you are right. This fellow, when B comes, yes, you are right. C, C, D. Very good. I think I am also agreeing to you. Very good. AACC. Okay. So the same logic. I hope I don't need to explain. I'm sure everybody is aware of it. So good. I think, okay, let me copy this also to complete the today's class finally. This is finally class. Okay.